Hi everyone. In this session we will learn about noise figure and noise factor. It is Sridevi, Professor, Department of ECE. On completion of this topic, the learners can able to calculate the noise figure and noise factor of RF system, and they can also understand the relationship between noise figure and noise factor. Let us know about noise factor first. So here consider one network having the input signal to noise ratio and output signal to noise ratio. Input signal to noise ratio is represented as S by N input IN, and output signal to noise ratio is represented as S by N OUT output. Noise factor, that is the measure of degradation of the signal to noise ratio in the device. Simply we can divide the noise ratio as, that is the ratio of input signal to noise ratio to the output signal to noise ratio. So that is here input signal to noise ratio it is considered as X, and output signal to noise ratio it is considered as Y. So X by Y, that is called as noise factor. So input signal to noise ratio divided by output signal to noise ratio is called as noise factor. That is it's the ratio of signal to noise ratio at the input to the signal to noise ratio at the output, that is called as noise factor. Simply by using this formula, noise factor equal to signal to noise ratio at the input IN divided by signal to noise ratio at the output noise figure. So noise figure performance of a radio receiver, amplifier, mixer or other circuit can be calculated for better performance. So for better performance, one circuit should produce better noise figure. So having one circuit having input signal to noise ratio Si by Ni, output signal to noise ratio S0 by N0, the noise N is given as noise figure N is given as 10 log to the base 10 Si divided by Ni divided by So divided by No, that is N. N is noise figure. So noise figure can be, noise factor is calculated as F, noise figure which is calculated in dB is 10 into noise factor is called as noise figure. So 10 into noise factor, that is equal to noise figure. So noise factor simply output signal to it is the ratio between input signal to noise power divided by output signal to noise power. So noise figure is 10 into noise factor. So here we have one block diagram, signal to noise ratio at the input divided by signal to noise ratio at the output. The relationship between noise figure and noise factor is, noise figure in dB is equal to 10 into log noise factor. So here noise figure in cascaded systems, let us consider the cascade system. Cascade means the output is given as the input of another system. First system output is given as the output of the second system. We have the first system G1 and second system G2 and third system G3. First system output is N1, NF1, second system output is NF2 and third system output is NF3. First system output is given as the input of second system G2 and second system output is given as the input of third system G3. So noise gain is equal to G. Let us consider G equal to gain. The noise figure is equal to NF. So here there will be the noise form of first stage and it will be amplified by the second stage, and finally there will be noise form in the second stage. However, often we have the RF system design process. We have to calculate the effect of performance of different stages to calculate the overall noise performance of the system. So to find the overall noise performance, each and every individual systems are calculated, and the overall performance is calculated. So overall noise factor Fn is equal to, first one F1 plus F2 minus 1 divided by G1 plus F3 minus 1 by G1 G2 etc. up to Fn minus 1 by G1 G2 etc. up to n minus 1, that is overall noise factor of the system. So noise this overall noise factor, from this we can calculate the overall noise factor of the system. So we have one quiz question here. For 3-stage cascade amplifier, calculate the overall noise figure when the system has the gain of 12 dB and the noise figure is 8 dB. Noise figure is given and noise factor is also here. Gain is also given, noise figure is also given. The answer given is 13.55. Let us find how this 13.55 we are getting. So, as we know the formula to calculate the overall noise that is F1 equal to F1 plus F2 minus 1 divided by G1 plus F3 minus 1 divided by G1 G2 plus etc. up to F1 minus 1 by G1 G2 G3 into Xn. So, here F1 F2 F3 etc. up to Fn and G1 G2 G3 etc. up to Gn are the noise figures and the gain. F is noise figure and G is the gain. It is given F1 equal to 12, F2 equal to 12 and F3 equal to 12 because here for 3-stage cascade amplifier overall noise figure when each stage has a gain 12 and 12 dB and noise figure is 8 dB and it have all the values are same. So, F1, F2, F3 3 stages given. So, all these values are 12, G1, G2, G3 are given. So, substituting this value in the formula Fn equal to F1 plus F2 minus 1 divided by G1 simply etc. up to 3 stages, substituting the value equal to 13.55. And another question is based upon noise factor. Noise factor for a system is defined as a ratio of from the definition we know it is the output signal output noise power to the input noise power, that is called as noise factor. Hope you all understood this session. Thank you.